So here it's given that A, G, and H represents the arithmetic, geometric, and harmonic means of two positive numbers A and B. Now immediately it follows that the arithmetic mean of A and B will be given by A plus B over 2. Then we have the geometric mean, which is given by square root of AB. Then we have the harmonic mean, that will be simply 2 times AB divided by A plus B. Now let us suppose that let these numbers A and B be the roots of a quadratic equation. Now we know that whenever the two roots of a quadratic equation are given to us, then the general equation will be given by x squared minus the sum of the roots. We have a plus b. This will be multiplied to x plus the product of the roots, which will become the constant. So this will be equals to 0. So all we have to do is replace the value of a plus b and ab, because we are given the value of a, g, and h. Now let's start with the arithmetic progression part. So here we can rewrite a plus b with 2 times the arithmetic mean. And if we consider the geometric mean, then g will be simply equals to square root of ab. But we need ab, so squaring both sides gives us g squared equals to ab. So that means we can replace the value of this ab with g squared and a plus b with 2a, such that we get x squared minus 2 times a times x plus g squared equals to 0. So this is going to be the required quadratic equation in terms of the arithmetic mean and geometric mean, provided we know the mean between a and b, the arithmetic and the geometric mean of a and b. Okay. Now what if we have three positive numbers? So this time we have three positive numbers a, b, and c, and a is the arithmetic mean, g is the geometric mean, and h is the harmonic mean. Then immediately we can say that the arithmetic mean of these three numbers will be simply their sum. So we have a plus c, this will be divided by 3. Then we can define the geometric mean as the product of a, b, and c, but this time we'll have to take the cube root instead of the square root, since we have three numbers. Now, in order to define the harmonic mean, what we'll do, we'll take the reciprocal first. So 1 over h will be simply equals to, we have the three numbers, 1 over a plus 1 over b plus 1 over c. Those three numbers are going to be in arithmetic progression. So we take the arithmetic mean of the reciprocals of each term. This will be divided by 3. So we have 1 over h. This will be equals to, we have ab plus bc plus ca. This will be divided by 3abc. Fine. Or simply, if we take the reciprocal, so we have 3abc divided by ab plus bc plus ca. Now, let us suppose that a, b, and c are the roots of a cubic equation. Now, if we know the roots of the cubic equation, then the general equation is given by the formula. We have x squared minus sum of the roots. We have a plus b plus c multiplied to x squared. Plus we have the product AB plus BC plus CA times X minus ABC. This will be equals to 0. So this is the general form of the cubic equation. Now what we'll do, we'll start with the arithmetic mean. Now here we have A plus B plus C. So that will be equals to 3 times A. Fine. Then we need AB plus BC plus CA. For this we can take the help of the harmonic mean. So clearly AB plus BC plus CA. So that will be equals to 3ABC divided by H. We'll come back to this in a moment. So here we can also define ABC. So ABC is simply going to be equals to G cube. So that means we can replace this ABC with G cube to get 3G cube over H. Now what we'll do, we'll substitute all of these values into the general equation of the cubic equation, general form of the cubic equation. So we have x squared minus 3ax squared plus, so we have AB plus BC plus CA, which is simply 3G cube over H times X minus G cube equals to 0. And this is going to be the cubic equation, or the general form of the cubic equation, in terms of the arithmetic mean A, the geometric mean G, and the harmonic mean H.